In today's lecture, we will learn how to write the program code using Dijkstra algorithm. Before writing this program code, it is my request to everybody to solve at least one problem using Dijkstra. You know that for Dijkstra algorithm, you should have a graph that must be a weighted directed graph where the graph should not consist of any negative edge weight. So the graph visible here consists of 5 nodes 1, 2, 3, 4 and 5. It is a weighted directed graph and none of the edge weight is of negative. So as Dijkstra is a single source shortest path algorithm, deciding any one of the vertices as a source, you can calculate the shortest path from that vertex which you consider as a source to other vertices. That means if you consider vertex number 1 as a source, then applying Dijkstra you can calculate the shortest path from 1 to 2, 1 to 5, 1 to 3 or even 1 to 4. So before proceeding to implement of any graph algorithms, that may be Dijkstra, that may be DFS, that may be BFS, whatever it is, or even if it can be Prim's or Kruskal, you have to build up a cost matrix of the graph. Otherwise you cannot represent the graph in memory. So as the graph consists of 5 vertices here, so the cost matrix should be 5 cross 5. So here I have formed the cost matrix in such a way, if there is no edge in between 2 vertices, I put 0. If there is an edge between 2 vertices, I put the edge weight. For self loop, I consider 0 because in this graph there is no self loop. So it is a 5 cross 5 cost matrix, 1, 2, 3, 4, 5, 5 row and 1, 2, 3, 4, 5 columns. Row counter is I and column counter is J. So if I proceed for first row, so basically I am forming the cost matrix in such a manner. That means row number 1 means I am considering vertex number 1 and column number 1 means 1, 1. That implies is there any edge in between 1 to 1? If I read at first row second column, that implies is there any edge from 1 to 2? Similar 1 to 3, similar 1 to 4, 1 to 5 and so forth. Similarly, whenever I scan row number 2, that means I am at vertex number 2 and I am going to identify is there any edge in between vertex 2 to others. That means 2 to 1, 2 to 2, 2 to 3, 2 to 4, 2 to 5. In that way I can form the cost matrix of the graph. So let us consider the first vertex 1. So row number 1, 1, 1, there is no self loop, so I have put 0 here. Then 1 to 2, 1 to 2, yes, there is an edge and the cost is 10, so I put 10 here. 1 to 3, there is no direct edge associated, so I have put 0. 1 to 4, the same rule, I have put 0. 1 to 5, yes, there is an edge and the cost is 5, so I have put 5. In this way I can form the cost matrix which will be 5 cross 5. As it is a single source shortest path algorithm, so I have to know, or I must know, which vertex I have decided to play as a role as a source vertex. So here assume that 1 as a source vertex. So you know in Dijkstra algorithm, if you go through the algorithm, it is my request again for everybody to go through the algorithm at least once so that you can write the program code easily. So for your reference, I have shown here, let me show here the Dijkstra algorithm. Dijkstra is the name of the method. G is the graph, that is a weighted directed graph without negative edge weight. W is the weight function and S is the source vertex. So as per the convention, you have to apply initialization method at first. Initialization method says there are 2 important parameters dealing with Dijkstra algorithm. One is shortest path estimate that we express as v.d, and another one is predecessor vertex which we express as v.pi. Initialization of the single source for the graph G along with the source vertex S means you have to put infinity for d value, that means shortest path estimate for all vertices before proceeding to the algorithm, and apply nil as the predecessor field, that is v.pi for all the vertices. Then as S is the source vertex, shortest path estimate of source becomes 0 and remaining as it is infinity, and there is no change for v.pi. Then you have to maintain a minimum priority queue where the vertices will be stored based on their D parameter value, that means based on their shortest path estimate. So if you can recall it, the second step of this algorithm is you are maintaining a queue, capital Q, which is also indicated in the algorithm, where G dot V, that means all vertices based on their D parameter value will be stored. So D parameter value for S is 0 and remaining infinity. So definitely S will be at the front of the queue because it is a minimum priority queue. Then the remaining vertices will be there. That implies you have to process S at first. And the remaining part of the Dijkstra, it is very simple. Unless and until queue becomes empty, you have to identify the minimum D parameter wala vertex. That means having D parameter value minimum. That will be U. That means you need to explode that vertex. Then apply union operation that I discussed already. Then for each vertex, you have to apply the relaxation process between that vertex and its adjacent. So very simply we can say that S is of having least D parameter value, so you have to process it at first. So T and Y are the adjacent, so you have to apply relaxation to T and Y with respect to S. So you know the formula of the relaxation. What is T dot D? Now as per the table, the T dot D is infinity. What is W of S to T? That is 10. So T dot D is found greater than S dot D, which is 0, plus W of S to T, that is 10. So 0 plus 10, 10 here, so infinity greater than 10. So we can reduce the cost here. That means we can reduce the estimate here rather. So the new value of T dot D from infinity to it is changed as 10. And what will be the predecessor vertex? Due to S you can reduce the estimate. So definitely the predecessor vertex for T will be S. In this manner you can do relaxation for Y. Then S is removed from the queue. What are the remaining vertices in the queue? T, X, Y and Z. So T dot D is found as 10, Y dot D is found as 5 and remaining 2 are infinity. So this is displayed here. Here it is 10, here it is 5. These 2 are the predecessor vertices. These are nil. So you remove it from the queue. So the among the remaining vertices, as per the D parameter value is concerned, Y is the minimum one because Y dot D is found 5, T dot D is found 10, X dot D and Z dot D are still infinity. So next you have to process Y. So in that case you have to identify who are the adjacent of Y, then go for applying relaxation if any. So in this way you can solve the problem. So basically Dijkstra requires one minimum priority queue in the implementation process, and source vertex must be identified, which I have called assume 1 as the source vertex. You must have the cost matrix. So how to form the cost matrix that I told? In our next approach I definitely mention as the 0 value in the cost matrix which you have formed here will be replaced as infinity. So that is our programming tricks. So how to form the cost matrix, and then we proceed further how to write the program code that I am coming. So cost matrix formation, I have a plan to do the cost matrix formation within the main function. So better to write it as within main function I will form the cost matrix. So cost matrix formation. So to form the cost matrix, I must ask the user to provide the number of vertices in the graph, which is n. So that is user input. Okay. And if the name of the cost matrix be cost, so I request you to declare it in global, so that you need not to pass this cost matrix as an argument to any other functions. So better to declare cost matrix as a global. So take the value of n from the user. Then you know it is a simple for loop structure for I equals to 1 to n. That is the outer loop. Then for j equals to 1 to n, this is the inner loop, that is I and j here. Then you have to accept the value of the cost matrix from the user. That means user has to put all these entries 1 1 1 2 1 3 1 4 like you applied in Prim's algorithm. So you have to accept the value from the user. So scanf integer type value one at a time, that's in percentage d, ampersand of cost of ij. So users provides the 25 entries one by one. First 5 entries for the first row, second 5 entries for the second row, and so forth. So once a value comes from the user, let us apply one very simple checking. We will just apply if cost of ij is found 0. That means if any users provide 0 as an entry, definitely user will provide some zeros as an entry based on the graph, because user have to provide the cost matrix based on this graph. So 1 1, definitely user has to put 0 because there is no self loop for 1. 1 to 2, user has to put 10 as a value. So some of the zeros entries are there. So if cost of ij is 0, then I told I will replace it as infinity. Then cost of ij will be replaced as infinity. And I have written INF. So you know how to write INF. INF is basically a macro. So here you can declare it as has defined INF. Suppose a big value 999. So along with other header files you write this macro. So in this way you can form the cost matrix. So this is done, this is done. So our cost matrix formation is complete, and that will be done within main function. Okay, the second part, after taking cost matrix, as Dijkstra is a single source shortest path algorithm, you have to ask the user to provide which vertex will play the role of the source vertex. Suppose v is a parameter or the variable using which user can put the source vertex input. Okay, that you can do using under main function. Done. So your cost matrix is done, your source vertex has appeared. So the third part is very simple. You have to call the method that is called Dijkstra, that is Dijkstra, or you can put any name, Dijkstra. This function will play the main role to implement Dijkstra algorithm. There you can pass the number of vertices and the source vertex as argument. This is up to you. If you make all parameters as global, then you just call Dijkstra without any argument. Here I have make a plan to call Dijkstra applying this to argument. One is the total number of vertices, another one is the source vertex. Okay, because if you follow the algorithm, there are 3 parameters probably. One is the graph itself, second one is the weight function, and third one is the source vertex. So I maintain source vertex is one of the parameter here, and the graph can be traced if you know the total number of vertices, because n is there means you know the dimension of the graph, that means n cross n. So in this way I have somehow make a balance between the algorithm and my implementation. Okay, so after that there will be the print of the matrix, that means the output of the Dijkstra, so forth. You can show the path here. So at step 4 you can show the path here, that means the distances you can show them, and that means shortest distances you can show here. So then you can close the main function. So there is no other responsibility played by main. One is cost matrix formation, and I have formed the cost matrix in such a way, if there is 0 entry in the cost matrix provided by the user, that will be replaced by infinity. So here in this cost matrix, all zeros, this one, considering this 3, this one, then all will be replaced by INF. You will get the benefit of replacing zeros by INF whenever we proceed to the Dijkstra function or the next part of the algorithm. So the first part is very simple, that you can write the main function. Then second one, our main focus is to define Dijkstra. So our function name is Dijkstra, probably Dijkstra, and we have 2 parameters there. One is the total number of vertices, and second one is the source vertex. So I am not writing the full program code, so I may skip the data type portions also. So normally we are used to write int n, then followed by int v. Sometimes I will omit this data type, because here I am just discussing the way to write the program code. I may omit the return type of the Dijkstra. This is your task to accommodate or apply appropriate data type, whether it may be void or whether it may be any appropriate data type. That is your task. So under Dijkstra, first of all, our first approach is to maintain a one-dimensional array that is called a status array. This status array dimension will be 1 into n. That means the status array is a one-dimensional array. If the graph consists of 5 vertices, the first 5 cells of the status array will be utilized because it will keep the track of the status of the vertices. If the vertices will be visited, then the value of that vertex will be 1. That means it is already visited. That means it will consist of some boolean value, either 1 or 0. For a particular vertex, suppose it is a status array. Your graph consists of 5 vertices, I told. If you go through the graph, your graph consists of 5 vertices. So your status array length will be 1 into 5, single row, 5 columns. Basically it is a 1D array. So if you start indexing from 1, so 1 index means vertex number 1, 2 index means vertex number 2, index 5 means vertex number 5. Initially the status vertex all field will be filled up by 0 because you have not applied the algorithm, you have not started the algorithm, so no vertices have been visited now. Okay, so as per the convention, you have total n number of vertices, so definitely this 5 is basically n. Okay, so first of all you have to maintain a status array. So a simple for loop will help you to do it. For I equals to 1 to n, under for loop you have to write status of I equals to 0. That means all vertices status is 0. That means no vertices have been explored yet. Apart from this one, I told you Dijkstra algorithm maintains a minimum priority queue, and say the name of the minimum priority queue is dist. So it is basically a 1D array like, because if you go through the data structure and algorithm course, there you will find the concept of stack and queue can be implemented with the help of a 1D array. So here also we use the queue in the form of an array. That means applying array we can implement the queue, or we will represent the queue. So as there are 5 vertices in the graph, so definitely the length of the queue you can assume at 5. Okay, and name of the queue is suppose dist, dist, and the name of the status array I told it is status. Okay, so now it is very interesting. If I write dist of I equals to cost of vi, you know that in dist array or minimum priority queue, here we will store the vertices based on their d parameter value, that is based on their shortest path estimate, and the vertex having minimum shortest path estimate will be processed first. And you know that as per the algorithm, source vertex is of having minimum shortest path estimate at the beginning, because apart from source, all vertices d parameter value after applying initialization process is infinity, and only source vertex is of having d parameter value as 0. So that's why we go for source for its exploration. So here dist of I equals to cost of vi, we will fill up dist of I in such a way so that we can form it. That means we can form the queue and then we can proceed further. It is very, very interesting, you see that. So here you read it. You know that v is the source vertex. Assume that vertex number 1 as a source. I told assume vertex number 1 as a source. Fine. So I equals to 1. V equals to 1. I told assume 1 as a source vertex. So the first iteration, status of 1 is 0. Status of 2 is 0. Status of 3 is 0. Up to status 5 all are 0. But how this dist array can be formed? Dist of I means at the first iteration dist of 1. Okay. 1, 2, 3, 4, 5. Dist of 1 equals to cost of vi, that means cost of 1, 1 when I equals to 1. Cost of 1, 1. What is cost of 1 1? Cost of 1 1 is infinity, because initially it was 0, but as we made this decision making block here, so all zeros are replaced by infinity, INF. So cost of 1 1 is INF. So it is INF. Then cost of 1 2, because I is 2 when, then this will be cost of 1 2. V is constant because V is 1 source vertex. So dist of 2 equals to cost of 1 2. What is cost of 1 2? Cost of 1 2 is 10. So actually you are reading the first row of the cost matrix. So cost of 1 3, then it is infinity, cost of 1 4 infinity, and cost of 1 5 it is 5. So right here INF and 5. Okay, so I am explaining it later on. So after that, you know that one of very interesting part, that is make dist of V equals to 0. You know that V is 1, so dist of 1 is 0. So it is like the process of the first part of the Dijkstra, which is called put infinity of all d values, okay, then make 0 as the d parameter value of source. So this array, this table, the first row only, forget about pi value, on the first row only is like the dist array. Okay, it maintains a minimum cost priority queue, and actually it is queue. This one actually it is queue. The queue is formed, the first part all are infinity, then 0, then the queue is formed, that is S, T, X, Z and Y. So this is the way that we can form here. So apart from source vertex d parameter value is 0, remaining infinity. These 10 and 5 means with respect to source, that is 1 here, as 1 is of having minimum d value at the beginning, so 1 should be explored first. So with respect to 1, 2 and 5 will be its adjacent. So 2 and 5 will get its first relaxation process. So 1 to 2 the relaxation value will be 10, 1 to 5 the relaxation value will be 5. It is not only the minimum priority queue, but from minimum priority queue with the infinity field along with one step forward relaxation with respect to source. So we will form this dist array that will play the role of the minimum priority queue, and from this dist array we will pick up the vertex which will be explored next. So here vertex 1 is of having 0 as a d parameter value, vertex 2 is 10, vertex 3 is infinity, vertex 4 is infinity, and vertex 5 is 5. So among these three, source is of having minimum d parameter value, so you need to apply relaxation with respect to source. So that we applied in our algorithm. That means here that I told S is of having 0 value, T, X, Y and Z, they are of having infinity value. So S is of having minimum d parameter value. So with respect to S you can apply relaxation to its adjacent. To its adjacent means T and Y. So S to T relaxation will be 10, S to Y relaxation will be 5. So after that this table is formed. Okay, so basically this is formed, and this will also play the role of maintaining, this will help to play the role, this will help to maintain the queue actually. So here also this you are getting, this part you are getting here. Okay, and you can consider this part is helping to form the queue, that is queue. Okay, so this is the significance. So now point 3, that is under Dijkstra. So for a graph, for total number of 5 vertices present, each vertex may cover at most 4 edges. Here one cover only one edge, 2 edge. One may cover, there would be an edge from 1 to 3. One may cover another edge 1 to 4. So for each vertex, out of total 5 number of vertices, one vertex can cover maximum 4 edges. So in terms of n number of vertices present in the graph, each vertex can cover at most n minus 1 edges. Okay, so that concept is applied here, because you have to apply relaxation, from a vertex to its adjacent. That's why I told a vertex in the graph may have at most n minus 1 edges. Here there are 5 vertices. If you explore one cover 2, one cover 5, but one could cover 3 and 4 if there is an edge from 1 to 3 and 1 to 4. So all possibilities, because this is dependent on the graph, but at most n minus 1 edges can be covered by a particular vertex. So keeping in this mind, so you will write a simple for loop. So for, say, count is a parameter, count equals to 2 count lesser equals to n, then count plus plus 2 to n, that is n minus 1. Vertex 1 is already covered. That means vertex 1 is covered means vertex 1 is already in the field, in the picture, which needs to be explored first. This is the meaning of covered actually. I wanted to mean. So now you have to identify from the list array which one vertex needs to be explored first. That means you have to calculate the minimum value from this array. Okay, so there should be a minimum value identification procedure. So now mean, let mean is a value, so let mean is a big value 999 like infinity, because some value needs to be set for comparison. So mean needs to be compared with 0, that means list of 1 actually. Mean needs to be compared with this one, so 0 and mean, 0 is the minimum, so that you can get the current minimum. So 0 with 10, 0 is the current minimum, 0 with infinity, 0 with INF, 0 in 5. In that way you will find that the first vertex is of having minimum d value. So that's why you set mean equals to 999. Then for the full vertices, that means for the full list array, you have to traverse. For suppose w is a counter, w equals to 1 to n, okay, so that you can cover it full. You have to identify if list of w, that is list of 1, list of 2, list of 3, if it is less than mean, okay, and status of w equals to 0, or anyone may write not equals to 1. That means pick up that vertex, vertex 1, vertex 2, vertex 3, vertex 4, vertex 5, which is not yet visited. Okay, because once you consider the vertex number 1, its value is 0 actually, that means d value is 0 here. So you compare with mean, fine. But once vertex 1 completes its execution, the array remains, but you should not consider it vertex 1 again, because as per the Dijkstra algorithm is concerned, once a vertex is covered, you need not to reconsider it. Okay, so among remaining vertices, you have to identify the mean. So once this one is visited, so its status field will also be 1. Okay, so both the parameter must to be checked. So if list of w less than mean and status of w not equals to 1, then mean will be w. Okay, that means not w, it is actually list of w, list of w. Okay, mean will be list of w, that means 0. Value is the new value, mean is the 0. And for which vertex? For vertex number 1 here, then it may be any vertex among 2 to 5. So, and this one, and u equals to w. So u is a parameter where I have stored, or I will store the vertex number for which its d parameter value is minimum. Okay, so this for loop completes. This for loop means this one, w completes. So the role of w is to find out or help us to identify the vertex which is to be explored next. Vertex number 1 to be explored first, or vertex number 2, or vertex number 3. And once the vertex completes its execution, then from the next iteration we should not consider the vertex again. Otherwise you will not going to identify the next vertex for its execution. Okay, So after this part is over, then close the inner for loop W. That means you have got which vertex is of having minimum D parameter value and which is stored into U. So after completion of it, you have to call the status array for U, status array for U, and set it as 1. Because once a vertex, suppose vertex number 1 is of having minimum D value, you know that you have to explore it. So before exploration, you make the status field of that vertex is 1. So that in future, whenever you are going to calculate the minimum D parameter value wala vertex from this dist array, vertex 1 will not appear. Because if you go through the checking here, the second checking says status of W should not be equals to 1 or should be 0. That means that implies this vertex is not yet visited or explored, rather not yet visited, not rather explored. Okay, so after that you have chosen that U is a vertex using which you go for relaxation. So U to others. So it is like 1, 2, 2, 1, 2, 5. This like. So use the first vertex. It was 10. It was 5. Okay. So now you have to go for relaxation. So the last part in the algorithm is called relaxation part. So I think it would be point number 4. And then point number 5, that is for relaxation. Relaxation process means I told you that you have to go for relaxation from that vertex to its adjacent. Okay, so you do not know how many vertices are adjacent of the current vertex which you are going to explore, and the current vertex means U here. So with respect to U, you have to apply relaxation. So you go for suppose W is a parameter, W equals to 1 to N. You will write if, the simple formula, if, it is very simple, dist of U. Dist of U we are calling because using dist array you know what is the present D parameter value of the vertices. Okay, either it may be infinity or it may be any non-infinity value or something. So dist of U plus, that is dist of U plus cost of this one, dist of U plus the distance from U to its adjacent. That means dist of U plus cost of U to W, because W is the parameter using which you can trace the adjacent of U. Actually, you are visiting the cost matrix where U is the row and W is the column. So using UW, you can identify who are the adjacent of U. So dist of U, that means its D parameter value plus cost of UW is less than the shortest path estimate of W. That means less than dist of W. Okay, dist of W. And you have to check again, and the adjacent which you are considering, whether it is already explored, that means still its status field is 0 or it is already explored. Because in the Dijkstra algorithm I told you earlier, once a vertex is explored, it will not come into the picture again, though it may be adjacent with respect to any other remaining vertices, but you cannot consider it. That means if you follow the graph, simple graph here, so here vertex number 2 and 5 are adjacent with respect to 1. So if 1 completes its execution, though 1 is the adjacent of 4 because there is an edge for 4 to 1, when you explore 4, you cannot reconsider 1. Okay, so this is the concept is implemented here. Very simple concept. That's why the adjacent vertex status must be judged. So not only the formula of relaxation, but also you have to call status array. Status of W, that is status of W not equals to 1, or anybody may write equals to 0. So if relaxation can be done and the status of W should not be 0, should be 0 or should not be 1, whatever you say. So then you can apply relaxation. That means you can apply relaxation in this segment to 2 and 5 with respect to 1, provided 2 is not yet explored and 5 is not yet explored. That means no other vertices has already covered. That means 2 has not yet explored. Yes, better to say it. So if this is possible, then it is a successful relaxation. Then you will write this of W, that is this one or this one, will get this new cost. This of W equals to, that is the formula of relaxation, this of U plus cost of U to W. Okay, so relaxation is done. So with respect to W equals to 1 to n, done, complete. No other part remaining for Dijkstra. So you have opened a count loop under step 3. So everything that we consider here will be under count. So here step 3 under Dijkstra completes. Okay, so this is the way that how to implement the Dijkstra algorithm. It is a very simple part, but you must have to be very careful about the algorithms and the necessary steps. That's why I told you to solve at least one problem using Dijkstra at first. So first of all, we have to form the cost matrix. We form the cost matrix in such a way so that all zeros entry will be replaced by infinity. That you know how to form it. Then ask the user to provide the source vertex, then call the function Dijkstra. Then at last you have to display the shortest distances. That is your task. Then Dijkstra takes two arguments. One is the number of vertices in the graph and the source vertex. Then first of all apply 0 as the status field of all the vertices, because initially no vertex have yet been visited. Then form a minimum priority queue, DIST. Calling the minimum priority queue, we will get the current shortest path estimate value of all the vertices. You know that initially when the initialization process is called, the D parameter value of all the vertices is assigned to infinity, and source vertex D value is assigned to 0. That is done here, and it is one step advanced formation, because here not only source vertex 1 is of getting 0 as this D parameter value, this means this one, okay, these two are infinity, and 2 and 5 as per the graph is concerned, first relaxation will be done for 2 and 5, because 1 is the source, it is of having 0 as the D parameter value. So 2 and 5 are the adjacent. So definitely with respect to 1, first relaxation will be for 2 and second relaxation will be for 5. So in this case here also 10 and 5 is stored. So it is not only the formation of the minimum priority queue, but also formation of the minimum priority queue at the first step and the second step. That means with respect to 1, the relaxation is also reflected here. But whatever reflection is there, if this could have been infinity, then also 1 is of having the minimum cost. So 1 needs to be explored first. Okay. So then dist of v equals to 0 means you put 0 here. That means the source vertex D parameter value is always 0. So this part is done. So how to call the cost matrix I told. Then for 2 to n, that is n minus 1 iterations, then you set mean equals to 999. So calling this dist array, you have to find out which vertex needs to be explored first. So 1 to 5, that means 1 to n, you have to call the array so that you can cover all the cells. Then set mean equals to 999 so that you can start initial comparison with a big value. So 0, that means dist of w, first one it is 0, needs to be compared with 999, and at the same time you have to see whether the vertex 1 have yet been covered or not. If it is not covered, then you have to consider it. Once vertex 1 have been covered, its status is 1. So from the next time when again you will call the entire array, you should not call vertex 1, because its status is 1. That means it is already visited. Visited means it is already explored here. So from the remaining you have to identify the mean. So that's why the multiple checking part is there. Not only dist of w less than min, but also there is an AND operation. So you have to check whether the status of w is already visited or not. That is not equals to 1 or equals to 0, like this. So then mean equals to dist of w. Then the value of the mean is dist of w, that is 0 at the first case, and u equals to w, that is u is the responsible vertex, that is a vertex number. So actually it is 1. So first time it is 1 because 1 is of having minimum d parameter value and you have to explore 1. Okay. Then the second part. So once you have selected the vertex number for exploring it, then that vertex status field must be 1. So status of u equals to 1 at the first time, and the first vertex, that is vertex 1, status will be 1. Then if you go through the queue, then as per my data is concerned, vertex number 5 will be of the next vertex for exploration. So then vertex number 5 status will be 1. So in that way you can proceed further. So then the last part, whenever you have chosen it u for a candidate for applying which you can go for relaxation with respect to u to its adjacent. So adjacent will be picked up using w. So dist of u, that means shortest path estimate for u, plus the distance from u to w, that is cost of uw, okay, less than dist of w. This is the simple formula of relaxation, and you have to judge whether this w, that is status of w, is not equals to 1. That means this is not yet visited, unvisited adjacent. Okay, then dist of w equals to dist of u plus cost of uw. This is the relaxation. So 1 to 2 there will be a checking, 1 to 5 there will be a checking, 1 to 4 as there is no adjacent there will be no checking, 1 to 3 there should have checking, but as they are not adjacent, so there will be no execution of this block. So in this way you can go for the relaxation. Once a relaxation part is over, 1 will be removed from the queue. Then 2 and 5 is of having the cost of minimum shortest path estimate of 10 and 5. So again you have to go back to this array. So it is 10, it is 5. So next you have to calculate mean again. So count equals to 3 to n. That is second time, third time, 2, second time actually. So 2, it starts from 2, 3 equals 3 to n. So again mean equals to 999, w equals to 1 to n. You have to again consider this full array. But in the next time you will not consider first vertex because its status is 1. So though you are going to judge this decision, but whenever you go for the second one, status of 1 is 0 because w starts from 1 means you have to go for dist 1, dist 2, dist 3, dist 4 and dist 5. So unfortunately dist 1 status is 1, so you cannot consider it. So among 2 to 5 you have to identify the mean. So definitely 5 is of having the minimum d parameter value, 5 will be the w and mean value will be 5. So in this way the status of 5, then status of 5 will be 1. So with respect to 5, that means with respect to 5 you have to apply relaxation to its adjacent 2, 3 and 4. So that will be done using this step. Okay, and then you repeat on further. So this is the way to implement Dijkstra algorithm. So the thing that I have mentioned here to display the paths actually, that is the shortest distance from one to others. So you can write a simple, very simple for loop for displaying it. It is very simple. So you may write a for loop like for I equals to 1 to n because you have total n number of vertices. So if I not equals to v, so vertex number I should not be the source vertex, so I should not be equals to v, then you can write a simple printf. You want to display like 1 2 2, 1 2 3, 1 2 4, like along with the cost. So it is like percentage d to percentage d, okay, double quote, it is like 1 to 2, 1 to 3 and the cost equals to percentage d. Okay, so it will be looks like 1 to 2 equal cost. Okay, so it is v because v is the source vertex, then I, so v to 2, v to 3, v to 4 because I not equals to v, v to 1, that means 1 to 1 will not be displayed. okay, vi, and where the cost is stored, shortest path estimate will be stored here. So that is the importance of the dist array. So this will play the role like minimum priority queue, from where you can pick up something, some vertex for which you need to go for exploration, and this is the array where you will get the final shortest path estimate. That's why in my lecture I told once and that it is like this one. That means this table is somehow formed, and this part also helps to implement queue. Okay, so this will play the dual role. You can take the vertex for exploration, and finally this table will help you to identify what is the shortest path estimates, final shortest path estimate, which will normally conventionally we call as delta. Okay, so you have to call dist of what? Dist of I. Okay, so in that way you can display the path. Okay, so go for algorithm first, solve one particular problem, then try to follow this lecture to implement it. Thank you.